Hello all. So in unit 1 we have seen the basic or fundamental concepts of AI, and then in unit 2 we have seen statistical learning, the maths required for working on machine learning algorithms. Today in this session we will start with unit 3. So unit 3 is all about supervised learning in that regression algorithm. So as we have already seen, machine learning algorithms are broadly classified into 3 categories: supervised learning, unsupervised learning and reinforcement learning. So unit 3 is all about supervised learning. In the context of supervised learning, again we have two different types of supervised learning algorithm. One is classification and regression. So in unit 3 we will be looking into regression algorithm, which comes under supervised learning. Okay, so when we talk about supervised learning, before we actually go into regression, let's see what is supervised learning was all about. So when I say supervised learning, it is one type of machine learning methods, learning systems, where we develop algorithms which will be trained on labeled data. When I talk about labeled data, as you can see here in the figure, this is my input data that I want to feed to the algorithm. Okay, now if I don't give any specifications about what that input data is, it is called unlabeled. Okay, but if I give specifications about the input data, it is called as labeled data. As you can see, I am just giving bunch of data and I am labeling them. So how am I labeling them? So I say these are rectangles, these are circles, triangles and hexagons. Okay, I am naming each of the input variables or input components which are available here. So this is called as labeled data. So usually supervised machine learning algorithms deal with labeled data. Okay, so what does the model do? Okay, so when you talk about machine learning, supervised learning algorithms, the model will learn from these input output pairs. Okay, so we already give the machine about the input data along with the labels, and the machine will read the shapes and then identify the names of that particular shape. Okay, now the goal in machine learning is actually to predict the output for new or unseen data. Okay, for example, here when I develop the model, I train the model with the existing data and I want to test the model with the new data. Okay, I give another shape of triangle or rectangle of different sizes and ask the machine to give me the predicted output. So here when I give another triangle or another circle, the predictions will be done by the model saying this is a triangle and this is a circle. Okay, so the data would be fed to the machine learning model. The model will understand the patterns in the data, and then when some other data is given, the model will predict the result for that particular data. Okay, so this is all about your supervised learning. Okay, so as discussed, when I talk about supervised learning algorithm, again we have two types of supervised learning algorithm. One is classification and the second one is regression. Okay, we often deal with regression when the output variable or when the output prediction is all about continuous values, and we use classification when your output variable has discrete values. For example, when I talk about temperature prediction, okay, so if the output of the temperature prediction variable is present in degrees, okay, in Fahrenheit or Celsius, okay, so when I ask you what is the temperature today, if your answer is about 34 degrees, 40 degrees, 41 degrees, 42 degrees, okay, we have continuous values at different times, right? So this kind of data where we have continuous values in the output variable, we go for regression model. Okay, sometimes when I ask you about weather, we also say if the weather is hot, the weather is cold. The answer is either yes or no. Or I may ask you if the weather is cold, the answer would be either yes or no. So I may ask you how is the weather, you may say cold or hot. Okay, so when you have discrete answer, we go for classification. So which algorithm to choose depends on the type of output target variable. Okay, if it has continuous values, we go for regression. If it has discrete values, we go for classification. So as mentioned here, discrete labels, for example, when I receive an email, okay, so categorizing the email into spam or inbox, okay, that is a classification task. When I talk about house prices, okay, so we have different range of houses like 2 BHK, 3 BHK, 4 BHK, duplex, independent house, etc. So we have different price ranges. So we have continuous values for the output prices prediction. So in this case, we would be choosing a regression algorithm. Okay, so classification models classify the outputs into certain categories. Okay, so if you have one category, two categories, we call it as binary classification. If you have multiple classes, we call it as multi-class classification. For example, type of flowers. Okay, so is this a rose or not? Yes or no is a binary classification. But if I put 5 different varieties of flowers and ask you to categorize these flowers, okay, rose, lily, lotus, jasmine and sunflower, okay, so these are different classes, right? So this is called as multi-class classification. Okay, so patient has cancer or not, yes or no, the answer is either yes or no, so that is called as classification task. Okay, when I talk about patient having cancer, the answer could be yes or no. If it is that, we call it as binary classification. If I ask what type of cancer does the patient have, okay, so throat cancer, blood cancer, liver cancer or whatever it is, okay, so if we have multiple categories, we call it as multi-class classification. It all depends upon the output variable that we choose. Okay, now when we talk about regression, it is all about dealing with continuous values, predicting how prices, how long does it take for you to reach home. Okay, so 2 hours, 3 hours, 4 hours, so it depends upon the time that you give. So when we have values that are continuously changing, we go for regression model. Okay, so when we talk about supervised learning, there are 4 important terms that we have to understand. First thing is input features. Okay, so we label them as X generally. Okay, so when I talk about input features, they are called as independent variables. Okay, independent in this is their input, we know the value, so not dependent. Okay, and then independent variables or attributes which are used by the model to make predictions. Using the input values only, we try to make the predictions. Okay, so when I talk about input features, they can be numerical data, they can be complex data like images, text, etc. Now, the second important component of supervised learning algorithms is output variables. Okay, so please understand, input features may be one or more, okay, which are called as independent variables. Output label can be one or more again, so this is called as dependent variables. Okay, so in classification task, basically we have discrete values like classify the animal, it is dog or cat. Okay, while in regression we have continuous values. Okay, now next thing is we talk about training data. When we develop a machine learning model, the input data that is given to the model will be divided into 2 parts, training data and test data. Training data is actually fed to the model for understanding or learning about the data, and after the machine learns about the data, we will test the model with the test data. Okay, it is as simple as listening to the class is training data, writing the exam on what you have learned is test data. Okay, depending upon your performance, we will decide how much you have grasped the topics or not. Okay, so that is all about your training data. And next, learning algorithm. Okay, learning algorithm is nothing but the algorithm or the model that we develop which will understand the relation between your input variables and output labels. Okay, so let's get into regression. Okay, so the first machine learning algorithm that we will start under supervised learning methods is regression. Okay, so let's start regression analysis. Basically, when I talk about regression analysis, it is important technique in supervised which is actually used to predict continuous values or continuous variables. Okay, now if you want to understand the relationship between input data and output data, okay, the primary goal of regression is to create a model that will actually predict the value of the dependent variable given the independent variable. Okay, X are independent variables, Y is dependent. So depending upon the relation that we have, we will try to predict the value of Y based on X. Okay, so that relationship is given by your regression analysis. Okay, so there are various types of regression techniques. For example, we have linear regression where we have only one or more independent variables, where we have only one dependent variable. Okay, so when I talk about multiple linear regression, we have multiple input variables. Okay, so when I talk about polynomial regression, instead of a straight line fitting all the input points, we have a curve. Okay, so there's another type of regression which is called as logistic regression. Though the name is logistic regression, basically this comes under your classification task. We'll discuss about all these things in detail in the upcoming sessions. So just remember that we have different types of regression algorithms. Okay, now not just that, depending upon the number of input variables that we take, also we have different categories of regression. For example, if you have only one input, okay, for example, I say depending upon whether a person has fever or not, predict if he has COVID or not. Okay, I am predicting a person having COVID based only on one input variable which is called fever. Okay. Okay, so if you have only one input variable, we call it as simple linear regression. Okay, if suppose under simple also, if the data is non-linear, not dependent, then we call it as simple non-linear. And if you have two or more variables, okay, so that is predicting COVID based on temperature, based on cough, based on the family history, based on some other parameters. Okay, I am predicting my output based on so many other input variables, we call it as multiple linear regression. Okay, if the data is linearly dependent, we call it as multiple linear. If it is not dependent, we call it as non-linear. Okay, now let's talk about the first basic algorithm. In order to understand regression analysis, let's dive into a simple regression model. Okay, so simple linear regression is a machine learning model that will actually gives us the relation between the dependent variable and independent variable. Okay, so the simple linear model is used as y is equal to mx plus b. We already know this, right? In mathematics, if you want to calculate the relation between two variables x and y, we give this particular equation, which is y is equal to simple linear equation, y is equal to mx plus b. Okay, so when I talk about x, this is input, which is called as independent variable, y, which is output, which is called as dependent variable, x, okay, x is m is nothing but the slope and b is nothing but the intercept. Okay, all of us know about a simple linear equation, right? Now based on this, we will calculate the dependency of output based on the input. Okay, now I am trying to draw a regression line calculating all the, see, I am trying to plot the graph between x and y here. I am calculating y based on the input variables x and also the intercept and slope. Okay, now depending upon the change in x, we also have change in y values, right? Now that is decided by the intercept and slope. For example, as you can see, this is a simple data. I call it a simple linear regression. Why? I am trying to predict the sales which is dependent. This is my output sales, which is dependent on this particular input variable, which is advertisement. Okay, so there's a marketing company called A who does various advertisements every year and gets sales on that particular thing. Okay, so advertisement is the input, sales is the output. Now for $90 spent on advertisement, the sales generated were about $1,000. For $120, the sales have increased to $1,300. For $150, it is $1,800. For $100, it is $1,200. For $130, it is $1,380. Okay, now this is the training data. Okay, now I want to test my model. First, I feed this particular input data to my machine learning model. It will have an understanding about how is the output generated, what is the value of output for each of the inputs given. Depending on that, when you give your test data, I am trying to test my model with new data, which is $200. For this, your machine has to predict the output variable. Okay, if I want to do this, I should actually know the relation between x and y. That is, how are the sales values getting changed based on the advertisement amount spent. Okay, now when I talk about this, we will actually draw a line based on x and y, right? Now how do we determine the best fit line? We will have so many lines, so how will we finalize the best fit line? Because depending upon intercept and slope, the lines get changed. Okay, previously I had this red line. When the slope is changed and intercept is changed, okay, I had another blue line. When I change it more, I have another blue line. Okay, so which is the best fit line? How do I decide? That is important when you talk about your regression analysis. Okay, so regression analysis is basically a statistical method in maths which we use for finding the relation between x and y, such that if you understand the patterns or dependency between x and y, your machine will learn the patterns and understand the output predictions based on the given input variable, such that when a new value is given, you will be able to predict the value of the output. You can predict the output for the given new input. Okay, this is all about your basic regression analysis. Thank you.